Assalamualaikum warahmatullahi ta'ala wabarakatuh. Welcome to MCTE 2311 Signal and System Analysis. So in this video, I will talk about transformations of signals. So these are the type of transformations on signals that we will see in this video. Okay, there are 5 of them. So the first one is amplitude scaling. Okay, so this transformation simply means that the amplitude is multiplied by a constant value, okay, of A here, for example. So let's say you have a signal G of t shown in this figure. Okay, so you can see at -2 it has a peak of -5, and at 2 it has a peak of 4. So let's say this signal undergoes an amplitude scaling transformation, okay, where the A is 1/2. Okay, so if you compare this original signal with the signal that undergoes a scaling of half, so you can see that now the amplitude is reduced. So at -2 instead of -5, now it becomes -2.5. Okay, so the amplitude now reduced by half. So at 2 instead of 4 here, it becomes 2. Okay, next one, you have your original signal here, and it is a scale by -1. Okay, so you can see that now the amplitude is shifted. Okay, the sign is changed. Okay, so at -2 instead of -5, you have now 5, and at 2 instead of 4, the amplitude becomes -4. Okay, so this hopefully shows you how the effect of amplitude scaling changes your signal. Next one, we'll look at time scaling, which is given by this equation. Okay, so y of t is the signal that results from scaling the time of the original signal x of t. Okay, so if you have the A greater than 1, it means the signal is compressed horizontally. If A is between 0 to 1, it means the signal is expanded horizontally. Okay, let's have a look at example here. So let's say this is your original signal, which is a unit triangular signal. Okay, and if the time is scaled by 2, as shown here, okay, it means that your signal is compressed by a factor of 2. So you can see that it becomes smaller. Okay, the width of the signal becomes smaller, okay, by half. Now if the time is scaled by half, as shown in this equation here, okay, it means that your signal is expanded by a factor of 2. So you can see the width here, okay, become wider. Okay, so instead of 2 unit here, now it becomes 4 unit. The next transformation is time inversion. Okay, which means for the original signal x of t, the time is actually scaled by -1. Okay, it means that y of t is the reflection of x of t about the y-axis. Okay, so for example, you have an original signal like this. Okay, so if this original signal is how to say, the time is inverted or multiplied by -1, you will get a resultant signal as shown in this figure. Okay, which means that the original signal is reflected about the y-axis. Okay, so now this minus t1 becomes positive t1, and this positive t2 becomes minus t2. The next one is time shift, okay, given by this equation, okay, which means in your original signal, the time is shifted by a certain amount t naught. Okay, so now if t naught here is greater than 0, it means that your original signal is shifted to the right or delayed. And if your t naught here is smaller than 0, it means that your original signal is shifted to the left or advanced. Okay. So for example, let's say you have a signal like this, which is actually a rectangular signal. Okay, and let's say this signal, okay, is how to say uh, undergoes a time shift of t minus 2. Okay, it simply means that your signal is shifted to the right by 2 seconds. Okay, as shown in this figure. Now if your signal undergoes a transformation of t plus 2, okay, it simply means that your signal, okay, is shifted to the left. Okay, so from here it shifted to the left by 2 seconds. Now you can also have multiple transformations, okay, in one go. For example, all 4 transformations, okay, can be applied simultaneously. So let's say your signal g of t undergoes this transformation where you have amplitude scaling, you have time scaling, and you also have time shift. Okay, so the first thing that you need to do is to break down the transformation into successive simple sub-transformations. Okay, so how do we do that? Let's take a look. Okay, for example, the first one you do is scale, okay, the amplitude by A. So you get A g of t. The next one you do is you scale the time. Okay, so the time now become t over a. So here change from t to t over a. The next one you perform is time shifting. So you change t to t minus t naught. Okay, so the t here you change to t minus t naught. Okay, so you get this equation which is equals to the equation over here. Now, you want to take note that order of sub-transformation is important. Okay, for example, if these two transformations, okay, the time scaling and the time shifting, you interchanged, you actually will get a different equation, okay, or different result. For example, like this, okay, where you perform time shifting first and then you perform time scaling, you will get a result like this, which is actually not equivalent to the transformation that is required by the question, for example. Okay. However, this does not mean that you cannot perform time shifting first. Okay, you can actually, but you have to do some modification. So if you change the order, okay, which means if you do time shifting first, okay, you have to shift it instead of just t naught, okay, you have to shift it by t naught over a. Okay, so after you do amplitude scaling, this t here you change to t minus t naught, so you get something like this. Okay, then you do the time scaling. Okay, so the t here you change to t over a, so you get t over a. Okay, like this, which is equivalent to this equation. Okay, which is the transformation that we want to perform. Okay, now you might how to say ask what kind of transformation that I need to perform. Okay, so actually different transformation will require different sequence. Okay, so you need to look at the equations properly and think and maybe do some trial and error. Okay, for example, if I want the signal g of t to undergo this type of transformations. Okay, so this will be the sub-transformation sequence that I will do. Okay, first I do amplitude scaling. So g of t become a g of t. Next one is I will do time shifting. Okay, so this t here will change to t minus t naught. Next is I perform times scaling. Okay, so the t here will become b of t. Okay, so I get this equation which is equals to the equation here, okay, which is the transformation that we want to perform. Now let's look at some sample problem. Okay, sample problem 1, you are given a triangular signal, okay, like this, with the mathematical expressions, and you are asked to sketch the new signal y of t after the original signal undergoes a time shifting transformation. Okay, in equation 1, it shift by +1, and in equation 2 it shift by -2. For problem number 2, again you are given equation, a signal x of t. Okay, in this figure you are also given the mathematical expressions. Okay, so the question asks you to perform the following transformations on this signal. Okay, so you have time inversion, and then you have time inversion and time shifting. Okay, so why don't you go ahead and try solve this problem, and as usual I will give you the solution to this problem in another video. So I see you later. Thank you.